Hello everyone. In this video, we will solve the numericals on the chapter Dual Nature of Radiation and Matter. So the first question is find the maximum frequency and minimum wavelength of X-rays produced by 30 kilovolt electrons. Okay, the first question is what? To find out the maximum frequency and minimum wavelength produced by 30 kilowatt 30 kilovolt electrons. So firstly they have given the V here. So what is V? That is 30 kilovolt, or I can write this as 30 into 10 raised to 3 volt, or I'll write it as 3 into 10 raised to 4 volt. So now we know the definition of the potential difference here. So V can be written as what? Energy per charge of an electron, or this energy is written as what? E into V, charge of an electron, and V is what? Potential difference. So mark this as the equation number 1. So now how to define the energy in terms of frequency here? So when the electrons which are on the metal plate will absorb the energy which will be having this amount. Okay, energy ಈ ಅಮೌಂಟ್ ನಿಂತ ಇರುವಂತ ಎನರ್ಜಿನ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಏನಾದರೂ ರಿಸೀವ್ ಮಾಡ್ಕೊಂಡು ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡು ಅಂತಂದ್ರೆ ಅವೇನ್ ಮಾಡ್ತಾವ? ಒಂದಿಷ್ಟು ರೇಡಿಯೇಷನ್ಸ್ ನ ಎಮಿಟ್ ಮಾಡ್ತಾವ. ಆ ರೇಡಿಯೇಷನ್ಸ್ ಎಷ್ಟು ಎನರ್ಜಿ ಇರುತ್ತೆ? h nu ಅಷ್ಟು ಎನರ್ಜಿ ಇರುತ್ತೆ. Okay, mark these 2 points here. This is equation number 2. This is the energy of the matter. This is the energy of the what? Radiation. Both are what? Energy only. So by comparing these two equations, what I can write is h nu is equal to what? E into V. This is nu is nothing but nu max. Okay, nu max. So we want for nu max only, right? That is what? Maximum frequency, that is nu max is equal to what? E into V divided by H. E is 1.6 into 10 raised to minus 19, and V is what? 3 into 10 raised to 4 volt whole divided by 6 point Planck's constant 6.63 into 10 raised to minus 34. So this you will get the answer as 7.24 into 10 raised to 18 hertz. Okay, this is what? This is maximum frequency. This is what? Maximum frequency. Next we have to find out for what? Minimum wavelength. ಮಿನಿಮಮ್ ವೇವ್ಲೆಂತ್ಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಸೊ ವೇವ್ಲೆಂತ್ಗೂ ಫ್ರೀಕ್ವೆನ್ಸಿಗೂ ಒಂದು ರಿಲೇಷನ್ ಏನದ? ವೇವ್ಲೆಂತ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಸಿ ಬೈ ನ್ಯೂ. ಇಫ್ ದಿಸ್ ಈಸ್ ಮ್ಯಾಕ್ಸಿಮಮ್, ದೆನ್ ಓನ್ಲಿ ಲ್ಯಾಂಬ್ಡಾ ವಿಲ್ ಬಿ ವಾಟ್? Minimum, because both are what? Inversely proportional to each other. C is speed of light, that is 3 into 10 raised to 8 meter per second, and V max is what? That is 7.24 into 10 raised to 18. Yes, in siktala ade V. Okay, so if you calculate this, you will get the minimum wavelength as 0.41 into 10 raised to minus 10 meter, or you can write this as what? 0.041 nanometer. Hingunu baradrunu nadiyutta, both are same only. Okay, got? This is the first question. So let's move with the next question. Next is the work function of the cesium metal is what? 2.14 electron volt. So they have given the work function. Work function ಏನಂತ ಕೊಟ್ಟಿದ್ದಾರೆ? Phi naught is equal to 2.14 electron volt. Next, when the light of frequency is nu, frequency 6 into 10 raised to 14 hertz is incident on the metal surface, photo emission of electrons occurs. So now what is the maximum kinetic energy of the emitted electrons, stopping potential, and maximum speed of the emitted electrons? They have asked these three parameters to find out. So one thing what we have to find out first here is the maximum kinetic energy. So maximum kinetic energy ki in formula that is h nu minus phi naught. E formula hang bantu because we know that the given energy will be took by two cases, that is one, the work function, plus the kinetic energy of the electrons, that is maximum kinetic energy of the electrons. That equation only we are using here. H is the Planck's constant, that is what? 6.63 into 10 raised to minus 34 Joule second. We will substitute that only here. H is 6.63 into 10 raised to minus 34. Next, nu. this is new ಎಷ್ಟದ in ನೋಡ್ರಿ, that is 6 into 10 raised to 14. okay, this is ಇದು ಬ್ರಾಕೆಟ್ ಒಳಗೆ ಬರ್ದಿದ್ದೇನಿದು h nu. okay, minus work function that is 2.14 electron volt. so ಈ 2.14 electron volt ನ ನಾವೇನ್ ಮಾಡಬೇಕು, ಫಸ್ಟ್ ಜೂಲ್ ಒಳಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬೇಕು. ಜೂಲ್ ಇದ್ದಿದ್ದನ್ನ ಹೆಂಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋತೀವಿ, that is into 1.6 into 10 raised to minus 19 joule. ಇದೆಲ್ಲಾನು ಸಾಲ್ವ್ ಮಾಡಿದ್ರೆ ನಿಮಗೇನು ಸಿಗುತ್ತೆ, that is 0.55 into 10 raised to minus 19. this will be in terms of joules, or you can write this in terms of electron volt. so electron volt ಒಳಗೆ ಮಾಡ್ಬೇಕಂತಂದ್ರೆ ಏನು ಬರೀತೀರಿ ನೀವು, 0.55 into 10 raised to minus 19 joule. electron volt ಒಳಗೆ ಬರೀಬೇಕಾದ್ರೆ divided by what, 1.6 into 10 raised to minus 19 ಎಷ್ಟು ಬರೀತೀರಲ್ವಾ. so this is, ಇದನ್ನ ನಾವು ಯಾವಾಗ ಬರ್ಕೋತೀವಿ, when we want to write the energy in terms of electron volt. okay, so if you calculate this, you will get the answer as 0.34 electron volt. okay, this is in terms of joules, this is in terms of electron volt. so now we got the maximum kinetic energy, that is in terms of joules it is 0.55 into 10 raised to minus 19. in terms of electron volt it is 0.34. next we want to write for what, second one, that is stopping potential. stopping potential ಗೆ ಮತ್ತೆ maximum kinetic energy ಗೆ ಇರುವಂತ ರಿಲೇಷನ್ ಏನು, that is stopping potential is given by what, V naught. so we know that maximum kinetic energy is equals to E into V naught, right? ಇದನ್ನ ನೀವು ನೋಡಿದ್ದೀರಾ when I was saying the conclusions or somewhat, you got there right. okay, so we want for V naught. so V naught is equal to maximum kinetic energy divided by E. E ಏನಿರುತ್ತೆ, 1.6 into 10 raised to minus 19 joule ಇರುತ್ತೆ, ಹೌದಾ, minus 19 joule ಇರುತ್ತೆ. next if you want to, sorry it's not joule. okay, this is what E kinetic energy. kinetic energy is what, here we have to take this, it is 0.55 into 10 raised to minus 19. okay, that is 0.55 into 10 raised to minus 19. this is in terms of joule, this is not joule. okay, now it is charge of an electron, that is 1.6 into 10 raised to minus 19. so when calculate you both ಇವೆರಡನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಂತೆ ನಿಮ್ಗೆ ಏನು ಸಿಗುತ್ತೆ, that is 0.34 volt. what you get, 0.34 volt. what is this 0.34 volt, that is stopping potential. stopping potential ಹೆಂಗೆ ಸಿಕ್ತು, ಈ ಫಾರ್ಮುಲಾದಿಂದ ನಮಗೆ stopping potential ಸಿಕ್ತು, that is kinetic energy, maximum kinetic energy is equal to charge of an electron into stopping potential, that is V naught. so ಅದರ ಮುಖಾಂತರ ನಮಗೆ ಸಿಕ್ತು. so next we want to find out what maximum speed. okay, maximum speed ಅನ್ನು ನಾನು ಹೆಂಗೆ find out ಮಾಡ್ಬೋದು, I can find out like we know that maximum kinetic energy is equals to what, we know that E V naught. yes, E V naught, or I'll write this as, yes, I can write this also as what, E V naught. ಇದನ್ನು ನಾನು ಏನು ಬರಿಬೋದು, maximum kinetic energy is equals to half mv square ಬರಿಬೋದಾ, and this will be maximum. and ಇದನ್ನು ಬರ್ಕೊಳ್ಳಲ್ಲ ಬೇಕು, now it is not necessary. I want this, why, because they have asked for what, speed. they have asked for speed, that's why. so we want for speed. so what we will do here, we will modify this formula for V. V maximum is equal to square ಅದಲ್ಲ, ಇದು ಈ ಕಡೆ ತಗೊಳ್ಳಂತಲೇ ಏನಾಗುತ್ತೆ, ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಗುತ್ತೆ. ಬಿಫೋರ್ ದಟ್ ಈ 2 ಈ ಕಡೆ ಬರಂತಲೇ ಏನಾಗುತ್ತೆ, 2 into kinetic energy. 2 into kinetic energy divided by m. ಸ್ಕ್ವೇರ್ ಅದ, ಈ ಕಡೆ ಬರಂತಲೇ ಸ್ಕ್ವೇರ್ ರೂಟ್ ಆಗುತ್ತೆ. so in square root it's 2 into kinetic energy ಎಷ್ಟದ ನೋಡ್ರಿ, it is 0.55. it is 0.55 into 10 raised to minus 19. yes, whole divided by m. what is that m? m is what, mass of an electron. remember the mass of an electron always will be 9.1 into 10 raised to minus 31 kg. already ನೀವು last chapters ಒಳಗದು ನೋಡಿದಿರಿ. okay, this is what, this is whole root. okay, whole root is equal to This is 9.1 into 10 raised to minus 31. So when you calculate this, you will get the V max as 3.47 into 10 raised to 5 meter per second. Or you can write also this as ಇನ್ನು ಕಿಲೋಮೀಟರ್ ಒಳಗೆ ಕೇಳಿದ್ರೆ ಹೇಗೆ ಬರಿಬೋದು ನೀವು 347 ಅಂತಾದ್ರೂ ಬರಿಬೋದು ಕಿಲೋಮೀಟರ್ ಪರ್ ಸೆಕೆಂಡ್ ಅಂತ. ಓಕೆ, ಸೊ ನಾವ್ ದಿಸ್ ಇಸ್ ವಾಟ್ ದ maximum speed of an electron, emitted photoelectrons. Okay, this is about the second question. Next we'll move with the third question here. So the photoelectric cutoff voltage in an experiment is 1.5 volt. So they have given cutoff voltage, that is V0 is equal to 1.5 volt. Next, what is the maximum kinetic energy of the photoelectrons emitted? A very simple question. We know that maximum kinetic energy is equal to E into V0. E is 1.6 into 10 raised to minus 19. Right. Yes, it is 1.6 into 10 raised to minus 19. Next, into V0. V0 is 1.5 volt. So, ಇವೆರಡನ್ನು multiply ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಏನು ಸಿಗುತ್ತಾ? That is 2.4 into 10 raised to minus 19 joules. Very simple question, direct question. This is about the third question. Next, about the fourth question. Okay, the monochromatic light of wavelength 632 nanometer. So wavelength ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡ್ರಿ, monochromatic light of wavelength 632.8 nanometer is produced on a helium neon laser. The power emitted is, power ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ, that is 9.42 milliwatt. ಏನಿದು milliwatt. ಇದು ನಾನು ಹೆಂಗೆ ಬರ್ಕೋಬಹುದು, 9.42 into 10 raised to minus 3 watt ಹಿಂಗೂ ಬರ್ಕೋಬಹುದು. ಓಕೆ, ನಾನು ಗಿವನ್ ಪಾಯಿಂಟ್ಸ್ ಬರಿತಾ ಇದ್ದೀನಿ. ನೆಕ್ಸ್ಟ್ ನಾವು they have asked us to find out the energy and momentum of each photon in the light beam. How many photons per second on the average arrive at the target irradiated by the beam? Here the beam have the uniform cross section which is less than the target area. Now how fast, the third one is how fast does a hydrogen atom have to travel in order to have the same momentum as that of the photon. Okay, they have asked some, firstly they have asked us to find out the energy and momentum. Energy is given by what here? Yes, energy, first we have to take here. Energy is given by what? H nu. ನಮಗೆ ನ್ಯೂ ಗೊತ್ತಿಲ್ಲ, ಅವ್ರು ನ್ಯೂ ಬದಲಿ ನಮ್ಗೆ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಇಲ್ಲಿ, ಲ್ಯಾಂಬ್ಡಾ ಕೊಟ್ಟಾರ. ಸೊ ವಾಟ್ ಈಸ್ ದ ರಿಲೇಷನ್ ಬಿಟ್ವೀನ್ ನ್ಯೂ ಆ್ಯಂಡ್ ಲ್ಯಾಂಬ್ಡಾ? ದಟ್ ಈಸ್, I'll write here, see, nu is equal to c by lambda. ಇದನ್ನ ನೆನ್ಪಿಟ್ಕೋರಿ. ಓಕೆ, ಫ್ರೀಕ್ವೆನ್ಸಿ is equal to c by lambda. ಆವಾಗಲೇ ಸಾಲ್ವ್ ಮಾಡಿದ್ವಲ್ಲ ಅದೇ ರೀತಿ. ಸೊ I'll write here h into c divided by lambda. H is what? 6.63 into 10 raised to minus 34. C is 3 into 10 raised to 8 divided by nanometer ada. So 632.8 into 10 raised to minus 9. ಇದನ್ನಿಷ್ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಏನು ಸಿಗುತ್ತಾ? 3.14 into 10 raised to minus 19 joules. You will get this answer. What is this? This is energy. ಅವ್ರು ಇನ್ನೂ ಒಂದು ಏನೋ ಕೇಳಿದಾರಲ್ಲ, that is momentum. P ಕೇಳಿದಾರ. ಓಕೆ, momentum P is equal to what? That is h by lambda. ಹೌದಾ? P momentum is equal to what? h divided by lambda. ಇದರ ರಿಲೇಷನ್ ನಿಮಗೆ ನಾನು ಒಂದ್ಸಲ ಹೇಳಿದ್ದೀನಿ, ಸೊ ಪ್ಲೀಸ್ ನೋಡ್ಕೋರಿ. P is equals to h by lambda. or ಇದನ್ನ ಆಕ್ಚುಲಿ ಹೆಂಗೆ ಬರೀತಿದ್ವಿ? That is what? Lambda is equals to h by p ಅಂತ ಬರೀತಿದ್ವಿ. ಇದನ್ನೇ ನಾವು ಈ ರೀತಿ ತಗೊಂಡಿದ್ವಿ. So h is what? Again it is a Planck's constant, 6.63 into 10 raised to minus 34. And lambda is 632.8 into 10 raised to minus 19. So when you solve this, you will get the P value as 1.05 into 10 raised to minus 27. Note idenada h divided by lambda. Okay, so can I write the momentum as what? kg meter per second bariboda ee riti. Okay, kg meter per second bariboda. Why? Because momentum is equal to mass into velocity. Mass is kg, velocity is meter per second. So kg meter per second. So this is what? Momentum. This is what? Energy. So this is the first one. Next one, they have asked us to find out how many photons per second on the average arrived at a target irradiated by this beam. Assure the beam to have the uniform cross section which is less than the target area. Andre ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರ okay. So now just assume that there is a torch here. Okay, there is a torch here. Okay, there is a torch. So torch ನಿಂತ್ರ ಹೊರಗೆ ಲೈಟ್ ಹೊಂಟದ ಅಂತ ಹೌದಾ, ಲೈಟ್ ಹೊಂಟದ ಅಂತ ತಿಳ್ಕೊರಿ. ಇಲ್ಲಿ ಒಂದು ನಮ್ದು ಟಾರ್ಗೆಟ್ ಅದ. ಓಕೆ, ಟಾರ್ಗೆಟ್ ಅದ. ಅವ್ರೇನು ಹೇಳಿದಾರ, ಈ ಟಾರ್ಗೆಟ್ ದಿನ ಕ್ರಾಸ್ ಸೆಕ್ಷನ್ ಏರಿಯಾ ಅದ ಅಲ್ಲ, ಈ ಏರಿಯಾ ಇದಕ್ಕಿಂತನೂ ಸಣ್ಣದದ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. ಓಕೆ, ವೆನ್ ದಿಸ್ ಏರಿಯಾ, I'll take this as A2. Okay, this area I'll take it as A2 and this I'll take it as A1. They have said that A1 is greater than A2. ಓಕೆ, ಅಂದರೆ ಏನು, ಇಲ್ಲಿ ಎಮಿಟ್ ಆಗಿರುವಂಥ ಅಷ್ಟು ರೇಡಿಯೇಷನ್ ಇಲ್ಲಿ ಫಾಲ್ ಆಗತ್ತಾವಂತ ಅರ್ಥ ಅದು. ಓಕೆ, ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಹಿಯರ್. ಸೊ ದೇ ಹ್ಯಾವ್ ಆಸ್ಡ್ ಹೌ ಮೆನಿ ಫೋಟಾನ್ಸ್ ಪರ್ ಸೆಕೆಂಡ್ ಆನ್ ಅನ್ ಅವರೇಜ್ ಅರೈವ್ ಎಟ್ ದ ಟಾರ್ಗೆಟ್ ಪಾಯಿಂಟ್. ಈ ಟಾರ್ಗೆಟ್ ಪಾಯಿಂಟ್ ಮೇಲೆ ಫೋಟಾನ್ಸ್ ಎಷ್ಟು ಅರೈವ್ ಆಗಿದಾವ ಅಂತ ಕೇಳಿದಾರ. ಸೊ ರಿಮೆಂಬರ್ ಹಿಯರ್, number of photons okay, emitted per second will be equal to power divided by energy. Okay, will be equal to power divided by what? Energy. Okay, when you take the power divided by energy, you will get the number of photons per second. ಎಷ್ಟಿರುತ್ತೆ, ನಂಬರ್ ಆಫ್ ಫೋಟಾನ್ಸ್ ಪರ್ ಸೆಕೆಂಡ್ ಸಿಗುತ್ತೆ ನಿಮಗೆ. ಸೊ ಪವರ್ ಏನದ ಅವ್ರು ಕೊಟ್ಟಿದ್ದಾರೆ, ದಟ್ಸ್ ವೈ ದೇ ಹ್ಯಾವ್ ಗಿವನ್ ದ ಪ್ಯಾರಾಮೀಟರ್ ಪವರ್ ದೇರ್. 9.42 into 10 raised to minus 3 and total energy they have given here, we have calculated here. Total energy is 3.14 into 10 raised to minus 19. So when you calculate this whole, you will get the number of photons per second as 3 into 10 raised to minus 3 into 10 raised to minus plus 3 into 10 raised to 16. Okay, the number of photons which are emitted per second is 3 into 10 raised to 16. Okay, I hope you got this. Yes, so the third one is how fast does a hydrogen atom ಎಷ್ಟು ಫಾಸ್ಟ್ಲಿ ಹೋಗ್ತದ ಅಂತ ಕೇಳಿದಾರೆ ಅವರು. ಓಕೆ, ವಿ ನೋ ದ್ಯಾಟ್ ದ ಮೊಮೆಂಟಮ್ ಫಾರ್ಮುಲಾ ಏನು ಬರೀತೀರಿ, m into v. ವಾಟ್ ಇಸ್ ದಿಟ್ v? ವೆಲಾಸಿಟಿ. ಇದು ನಮಗೆ ಬೇಕಾಗಿರೋದು ಅದೇ, ಎಷ್ಟು ಫಾಸ್ಟ್ಲಿ ಹೊಂಟದ. ವೆಲಾಸಿಟಿ is equal to what? Momentum divided by mass. Momentum ಏನದ, we found it here, that is 1.05 into 10 raised to minus 27. What is mass of an electron? What is a mass of an, what they have given here? Okay, they have given a hydrogen atom here. Okay, so ನೆನ್ಪಿಟ್ಕೋರಿ, the mass of hydrogen atom will be nearly equal to mass of proton. So what is the mass of the proton? That is 1.67 into 10 raised to minus 27 kg. So nanalli baribekagirodu mass of hydrogen atom or mass of proton, that is 1.67 into 10 raised to minus 27. So iveredu calculate madri, you will get the velocity as 0.63 meter per second. So this is about the fourth question. Next one, the energy flux of sunlight reaching the surface on the earth is 1.388 into 10 raised to 3 watt per meter square. How many photons per square meter are incident on the earth per second? Assume that the photons in the sunlight have an average wavelength of 550 nanometer. So students, energy flux, let me denote the energy flux as phi. Phi not another work function, energy flux another phi. Okay, energy flux they have given as 1.388 into 10 to the power 3 watt per meter square. Okay, so what is this energy flux? Energy flux is nothing but the energy per unit area per unit time. Okay, per unit area per unit time. So I can write this also as 1.388 into 10 to the power 3 joule per meter square per second. Okay, 1.388 into 10 to the power 3 joules. Idenidu actually this is nothing but joule per second. This is what watt. Joule per second anodi enu watt. So this flux is nothing but what I can take this as total energy. I can take this as what? Total energy. So how many photons anta kelidara. So they have given total energy. We have to find out the how many photons. And one more, they have given the wavelength. Wavelength as what? 550 nanometer. That is 550 into 10 raised to minus 9 meter. So we know the energy of each photon, that is E is equals to h nu. That is what? H is 6.63 into 10 raised to minus 34. We don't know the nu, that's why we'll write as C by lambda, that is 3 into 10 raised to 8 whole divided by 550 into 10 raised to minus 9. So if you calculate this, you will get the E as 3.61 into 10 to the power minus 90 joules. This is energy per photon or each photon. Energy each photon. But we want for what? How many photons are emitted out. So therefore from these two parameters, energy of each photon and total energy, what we can calculate is number of photons. It hengantandra, yes, that is number of photons. Number of photons is equal to total energy. Total energy divided by what? Energy of each photon. Total energy is nothing but what? Electric flux. That is 1.388 into 10 to the power 3 whole divided by 3.61 into 10 to the power minus 19. If you calculate this, the number of photons emitted are 3.85 into 10 to the power 21. Okay. This is about the fifth question. Okay. Next, we will take about the next for the next question, that is sixth one. In an experiment on photoelectric effect, the slope of the cutoff voltage versus frequency of incident light is found to be what? 4.12 into 10 to the power minus 15 volt second. Okay, calculate the value of Planck's constant. Idenidu, what they have given this is nothing but the slope. Calculate the Planck's constant and I will calculate ಮಾಡಬೇಕು. Okay, so listen here first. They have given a this here. What? In an photoelectric effect experiment, the cutoff voltage versus frequency. So we know the graph here. Yes, we know the graph. Here there will be frequency. Here there will be frequency, and here there will be what? Stopping potential, or you can say cutoff voltage, that is V0. So ಇವೆರಡರಿಗೂ ಏನು ಬರುತ್ತೆ ನಮಗೆ ಒಂದು ಲೀನಿಯರ್ ಆಗಿರುವಂತ straight line ಬರುತ್ತೆ. Yes, the straight line. Okay, when you extend this straight line, you will get somewhat here. Okay, this the intercept on the y-axis is called as what? Intercept. ಇದಕ್ಕೆ ಏನಂತ ಕರೀತಾರ? Intercept ಅಂತ ಕರೀತಾರ. Okay, I'll explain this you later. Okay, so they have asked us to find out what the Planck's constant, right? We know that what hν is equals to work function plus maximum kinetic energy, right? So this work function plus maximum kinetic energy can also be written as what? E into V0. This is what? Potential, stopping potential, and nu is what? Frequency. ಇವೆರಡರ ನಡುವೆ ನಾವೇನು ಮಾಡಿದ್ದೀವಿ? ಗ್ರಾಫ್ನ ಪ್ಲಾಟ್ ಮಾಡಿದ್ದೀವಿ. ಸೊ ಇಫ್ ಐ ವಾಂಟ್ ಟು ರೈಟ್ ದಿಸ್ ಫಾರ್ ಇ ವಿ ನಾಟ್, ಬಿಕಾಸ್ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ಗೆ ಇದು ಬರ್ಕೊಂಡ್ರೆ ನನಗೇನು ಸಿಗುತ್ತೆ? ಎಚ್ ನ್ಯೂ ಮೈನಸ್ ಫೈ, ಸಾರಿ ಇಟ್ ಇಸ್ ಫೈ ನಾಟ್, ಎಚ್ ನ್ಯೂ ಮೈನಸ್ ಫೈ ನಾಟ್, ಆರ್ V stopping potential is equals to H by E into nu minus phi naught. So this equation just seems like y is equal to mx plus c. ಹಿಂಗೆ ಕಾಣಿಸ್ತಾ ಇದೆಯಾ? y ಅಂತಂದ್ರೆ ಏನು? ಇಲ್ಲಿ y axis ಒಳಗೆ ಏನದ? ಇಲ್ಲಿ ಸ್ಟಾಪಿಂಗ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅದ ಓಕೆ. x axis ಒಳಗೆ ಏನದ? ಫ್ರೀಕ್ವೆನ್ಸಿ ಅದ ಓಕೆ. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ intercept is on this here. ಇದಕ್ಕೇನಂತಾರೆ intercept, that is nothing but this distance is called as what? Work function. Okay, ಇದಕ್ಕೇನಂತಾರೆ work function ಅಂತ ಅಂತಾರ. So now we have to find out what? Slope. They have given from these both equation, from equation 1 and 2, I can write this m is nothing but what? Slope. So m is slope is given by what? h by e. ಇವೆರಡು equation is h by e ಅಂತ ಬರಿಬೋದಾ? So here m they have given, that is 4.12 into 10 raised to minus 50, which is equals to h, that is 6.63 into 10 raised sorry they have asked us to find out the h only. H divided by e, that is 1.6 into 10 raised to minus 19. So now h is equal to what? 4.12 into 10 raised to minus 15 into 1.6 into 10 raised to minus 19. So we get the h as 6.59 into 10 raised to minus 34 joules second, which is nearly equal to the actual value of the Planck constant. So next question. A 100-watt sodium lamp radiates energy uniformly in all directions. The lamp is located at the center of a large sphere that absorbs all the sodium light which is incident on it. Okay, lamp first ಏನೇನು ಕೊಟ್ಟಿದ್ದಾರೆ ಅವ್ರನ್ನ ಬರ್ಕೊಳ್ಳೋಣ. Okay, they have given power is equal to what? 100 watt. Now the wavelength of the sodium light is wavelength of the sodium light is 589 nanometer. 589 nano means 10 raised to minus 9 nanometer. Now they have asked what is the energy per photon associated with the sodium light. Energy per photon ge eshtanta kelidara. Next they have given at what rate are the photons delivered to the sphere. So energy of each photon, that is E is equals to h nu. So E is equals to h nu. We don't know the nu here. They have given lambda, that is hc by lambda anta formula na change ಮಾಡ್ಕೊಳ್ಳೋಣ. Okay, that is what? H is what? 6.63 into 10 to the power minus 34 and C is 3 into 10 to the power 8 divided by lambda. Lambda is 589 into 10 to the power minus 9 here, 9. So if you solve this, you will get the energy per photon as 3.38 into 10 to the power minus 19 joule. Okay, this is energy of each photon. Now they have asked the second one as rate, at what rate the photons delivered to the sphere. So a rate of photons of Kelidre, it is nothing but the number of photons only. It is nothing but what? The number of photons only. So as per the data given here, number of photons enagutta, that is n is equal to power divided by E, energy only. So power is 100 watt, energy is 3.38 into 10 to the power minus 90. So number of photons are 2.96 into 10 to the power 20. Right here, 20 photons per second. Okay, 20 photons per second. Okay, a very normal ಫಾರ್ಮುಲಾಸ್ನ ನಾವು ತಗೊಂಡು ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಜಸ್ಟ್ ಫಾರ್ಮುಲಾಸ್ನ ನಾವು ಮಾಡಿಫೈ ಮಾಡ್ಕೊಂಡು ಸಾಲ್ವ್ ಮಾಡ್ತಾ ಹೋಗಬೇಕು. ಫಸ್ಟ್ ವಿ ಹ್ಯಾವ್ ಟು ಕಲೆಕ್ಟ್ ದ ಡಾಟಾ ವಿಚ್ ಆರ್ ಗಿವನ್ ಇನ್ ದ ನ್ಯೂಮೆರಿಕಲ್ ಇಟ್ ಸೆಲ್ಫ್, ದೆನ್ ವಿ ಹ್ಯಾವ್ ಟು ಅನಲೈಸ್ ದ ಫಾರ್ಮುಲಾ and we have to solve it. Okay, next question. The threshold frequency of a certain metal is threshold frequency. Okay, threshold frequency of a certain metal is 3.3 into 10 to the 14 hertz, 10 to the power 14 hertz. If light of frequency, that is what? If light of frequency 8.2 into 10 to the 14 hertz is incident on that metal. Predict the cutoff voltage for the photoelectric emission. Okay, cutoff voltage ಎಷ್ಟು ಅನ್ನೋದನ್ನ ನಾವಿಲ್ಲಿ ಫೈಂಡ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. So here what we have to take, that is the kinetic energy formula. Yes, we have to take the kinetic energy formula, that is kinetic energy is equals to h nu minus phi naught. We have to just modify the formulas. Kinetic energy ನಾನು ಹೆಂಗ್ ಬರಿತೀನಿ, E into V naught as per the data. Okay, E into V naught we want for E naught, V naught ಗೆ ನಮಗೆ ಬೇಕು. Okay, that is h nu. Okay, minus phi naught and heng barkobodu nana. Phi naught is written as what, like this, right? So h into nu naught. Okay, now what we want for V naught. So h by E nu minus nu naught. So 6.63 into 10 raised to minus 34 divided by 1.6 into 10 raised to minus 19. Nu is 8.2 into 10 to the power 14 minus 3.3 into 10 to the power 14. Then we will get the cutoff potential, or the cutoff voltage as 2.03. Sorry, 2.03 volt. What? 2.03 volt. Okay, a simple formula. Next one. Yes, this is